My name is Omidiora Samuel. I'm a DevOps engineer at Active and Terragon Group. So at Terragon Group, we have over 65 servers that we manage currently. So I'll be talking about how we use AWS Cloudformation to manage our servers. So my agenda for this talk is to talk about what's CloudFormation, an anatomy of CloudFormation templates, what's Troposphere, and I'll be doing a simple template using Troposphere templates would help them solve a particular problem they might have, which is if they have different clients and they have different infrastructure they want to deploy for them, how do they manage it using AWS CloudFormation? They will about the manual route of having to go and create servers one by one for each of the clients, or is there a way for them to automate it? Anatomy of CloudFormation templates. Discuss about parameters. So parameters, the parameter section is used to pass values into your template when you create a stack. So a stack is generally just a collection of AWS resources. So there's like now I want to host a website, and then you want to host a site on the NG website. So the stack basically will consist of EC2 instance, Route 53, GMS configuration, and maybe you decide to store static files in S3 bucket. So as you can see here, so parameters consist of the parameters key and then an instance type parameter. So parameters essentially allows us to accept values from a user. So basically, as a mean for our PyHost company that we're using as reference, if we decide that we want to use T2 micro, which is a type of EC2 instance that has a 1 GB of memory, and then we also as performance enthusiast, so you want to, you can run a very large processing request to your website on the T2 micro. For those of us that are familiar with AWS here, so your website cannot scan to crash. So we have our value, so we have the type string. Well, then we have the default value of T2 micro, and then we have our values of T2 micro, M1 small, and M1 large. So which are different types of EC2 instances on AWS. And then we have the description there, which says enter T2 micro, M1 small, or M1 large, equal to T2 micro. So basically, what this just allows us to do is accept consistent type parameter. So assuming for our PyHost company, they decide that, okay, for their test environment, they will be making use of T2 micro, and then for their production environment, they want to decide between M1 small and M1 large. So you can see there that it has the allowed value. So it enables the user, whoever is configuring the service, to pick between 3 values. So it sort of prevents in a scenario where someone comes to your company tomorrow and then decides to go for a C3 large, which probably reduces cost and all. So that's all the parameters. You can see a link below which you can use to read up on it. So mapping section matches the key to a corresponding set of main values. So our PyHost company, okay, they decide that, okay, they want their users in US to access from the US availability zone. They want their users in Europe to access from the Europe availability zone. So with regional map, they can specify, and assuming they have different content for each user, with regional map, they can specify, okay, with each of these availability zones, I want this particular AMI to be deployed. What an AMI is basically is Amazon machine image.
So it's like a prefiguration of tools and let's say softwares that you can easily deploy on Amazon Web Services. So going on to the next one, which is resources. So resources section, which is the most important aspect of it all, declares the AWS resources that you want to include in the stack. So such as the Amazon EC2 instance, your S3 bucket. So your resources could include the whole Amazon Web Services Amazon Web Services provision. So you could include your Route 53, your CloudFront configuration, your S3 bucket, and the likes. So basically, what your resources contain is what? Okay, I want to deploy a static website on using S3, Route 53, and CloudFront for failovers and stuff. So my resource section will contain that, and it enables me to sort of, in a way, manage my deployment. So moving on to the next one, output section. So output section declares output values that you can import into other stacks. So all of this will actually make sense in a minute when I show how they all work interoperably together. So conditions. So conditions section includes statements that is defined and when a resource is created or when a property is defined. So assuming, like earlier on, we declared a parameter type of of instant type. So peradventure we want to do a scenario whereby if we're in a test environment, I want 2 gig of RAM instance, and if I'm in a production environment, I want a 4 gigabyte instance. A conditions section will fit that perfectly. So what is troposphere? So troposphere is a Python library that allows for easier creation of AWS Cloudformation JSON by writing Python code to describe AWS resources. And troposphere includes some basic support for OpenStack resources. So basically what troposphere does is it allows you to write JSON, because mostly you write your CloudFormation template in either JSON format or YAML format. But looking at the way JSON is for developers that are here, you understand that it has this kind of funny structure, and then with AWS and its DSL, there's no possible way for you to remember every particular DSL command for AWS CloudFormation templates correctly. So troposphere helps you to manage that by giving a programming interface to that, and it becomes easier for you to remember because it becomes something you're familiar with. You don't have to start remembering JSON values and key pairs. So so let's create a sample template. So I'll be using this. Can everyone see this? I'm trying to zoom out. Can we see it very? Okay. No. Okay, so you can actually check it here on my GitHub repo. I believe there's Wi-Fi connection. So I believe you can see this. Sorry? I should zoom in, okay. Is it better now? Okay, so we can see I have my CloudFormation.py, and I have some specifics: get attributes, output, find a map, and reporting from values and libraries I'm importing from the troposphere library. So we can see for the first on line 5, I have my T, which equals to template. And then on line 7, I'm adding a description, which is basically Python CloudFormation template test. Then on line 9, I'm declaring a parameter. So basically what I want to achieve here is to create a CloudFormation template that will help me deploy an Amazon EC2 instance along with volume that you can attach to the EC2 instance and a mount point that I'm specifying in the template. So basically, we have a parameter type that I'm adding, and then I have a region map I'm also specifying in the code on line 18. So I'm adding a mapping to the template, which I already initialized on line 5. And then I have my conditions, which is create production resources, which checks to see if the environment type, which I'm accepting as a parameter here on line 9, is production. So the way it works is this condition checks if my environment type, so when I input a value, when I select the environment type during when I want to create my stack, did I pick production or did I pick test? So it checks if it's test. That's what the condition does basically. And I'm adding it on line 33. So then on line 35, I have my resources declared. So I have my EC2 instance, my new volume, and my mount point. So you can see my EC2 does instance, the image ID. So I'm using a find a map function that essentially uses the mapping I added on line 18 to pick an AMI image, which is an Amazon machine image from the region map, so as to deploy on my stack. Then we have the output, which is the volume ID, then the value of reference. And then I'm printing it down to JSON. So Troposphere enables me to do all of this, so I don't have to worry about doing something like this with AND. So this is the output you get from Troposphere. So you can see it's kind of stressful having to remember all of this without Troposphere. So basically, when you use Troposphere, it helps you generate this JSON format, which you can now input, which can now load on the Amazon Web Service website, or you can use the AWS CLI, whichever you prefer. So as you can see here, the JSON output generated by the CloudFormation troposphere library that I've used here is over here in the output.json. And then we can see my condition, create prod resources, create production resources essentially. And you can see my resources that I declared here. That's the 929, which is my EC2 instance, my mount point, which is type of EC2 volume attachment and the likes, new volume, and then output. So you can check out this on my GitHub repo, so to get a clearer view. So basically, that's just what I just put. So let's input our sample template into AWS. So I'll be showing a series of images right now. So you can check them out on the link on my IMGO account, sampaski.imgo.com. So if you'd like to follow along, I'm not sure it will be very clear, so you could just check this out and you see the PyCon CloudFormation template. So can you see the image? Is it clear? Okay, so you can see here we have the create stack, and then you can see select templates. This is the Amazon Web Service UI for CloudFormation, and we can see choose file, upload templates to Amazon S3. So our output JSON that is generated, we'll pick it from our local file system, and then we'll upload it. Then the next page is asks us to specify details. So as you can see on the second border, we have parameters. So those are the parameters we specified in our CloudFormation template. So if you have more than, which is environment type. So if peradventure we have more than one, it will ask us for the values for those parameters that we've declared in our template. Then we'll move on to the next stage, which is our options, and then it asks us to tag our instances. So if you are familiar with AWS very well, you know when you create a lot of instances, it starts getting messed up, and you have to start tagging them so you'll be able to track your instances and stuff and the likes. So tags enables you to find an instance that you've created easily. So on to the next stage. So it shows you a review of everything you've selected so far. So if you want to probably change anything, you could go ahead to change it. Then it creates it for you. So you can see, so we can see there on the events section, the place that is red highlighted. So we can see create in progress, and create complete. So those are the stages AWS goes through to create a stack for us that we've declared in the Amazon CloudFormation template. So then we can see the resources that were declared. So the EC2 instance that were declared in our CloudFormation template that I showed us earlier has been created, and you can see the physical ID. So, and then the parameters that were declared during setup. So we have the environment type and its test. So to wrap up, so using troposphere, so why should you use troposphere? Why should you not write your JSON format? Why shouldn't you just go direct and write JSON or YAML? So number one, it allows you to version control your infrastructure. So it gives an enable environment for you to understand, okay, we have version 1, version 2, version 3 of our infrastructure, and it enables you to manage it very easily. And then it makes it easy for you to test your infrastructure as a code. So unlike compare, you can't test your JSON output, but you can test your Python code. So it enables you to check for any errors, or perhaps someone forgot something. It gives the opportunity to check. And then it also allows you not to mix your infrastructure as a code and manual config. One thing I see people do most very regularly is mix up their server provisioning with cloud configuration management, which shouldn't be, but due to the tools available in the market right now, it allows you to do both. But normally you should have your configuration management separate from your server provision. So alternatives to CloudFormation is Terraform, which is really gaining steam right now in the open source community. So if you want to check it out, peradventure you guys are at your place of work, you don't have your infrastructure on AWS, so you can check Terraform out. So any questions?
Thank you. Questions, please. Okay.
Okay. First of all, if I understand like your talk properly, like CloudFormation allows, let me say me for example now, to build my own hosting company, something like that, right? Then as in for users to like select and configure their infrastructure. Yeah. So, okay. Really, I think as in I really like EC2, but Amazon, sorry. But the problem I have with Amazon is it's very difficult to find. Like they have a lot of services. So it's very difficult to find like documentation or like it's difficult to Amazon to learn. Like, so how did you learn about CloudFormation, and can you suggest resources for me or for everybody to check out so we can know more about the services that Amazon provides?
Okay, so what will you consider yourself a beginner, intermediate, or expert in AWS services? Intermediate. Okay, I'd say there are a lot of tutorials online actually, and I'd say AWS is a fantastic developer advocate. Actually, they put tutorials up on YouTube, so you can probably check that out. And then regarding learning, I'd say the best way to learn is to try hands-on. So probably get a free AWS account and try one of these things out. So the more you try, the more you learn, and the better you become.